So here's a really interesting challenge that one of my Year 8 students came across this week. And when I say they came across it, I set them the work about 10 days before that, but I set them level 1 or 2 of an online quiz. And by the time they got to level 3 and level 4, things were starting to get a bit serious, and they're like, "Sir, we're not quite sure how to do this." We know that if we get 20 plus, I'm going to say the base, and I'm going to call the circumference is C. And you add all those things up, you're going to get 70 centimeters. But we don't know what B is, and we don't know what C is. We can't just go, well, let's see, 70 minus 20 is 50. We'll halve those numbers. That's not going to work because you can't have the base and the hypotenuse the same length. The hypotenuse has to be longer. You could guess and check. You could definitely do that. And I had a student in another year who did just that. But there is a way to do this algebraically, which, of course, is what you wanted to do if you had numbers that were not going to play nice or not exactly be integers. So we start with this expression here, 20 plus b plus c equals 70, and I'm going to call that equation 1. Now, we can rearrange that. If we take 20 from both sides, we're going to be left with 50 on the right-hand side, and if we then take away b from both sides, we'll get c equals 50 minus b, and I'm going to go ahead and call that equation 2. You can also see how we could rearrange the exact same equation to make b the subject, and we get b equals 50 minus c, and we'll call that equation 3, and we're just going to keep those equations there. I then want you to remember Pythagoras. Well, Pythagoras says that a squared plus b squared equals c squared. In the case of this triangle, we're going to have 20 squared, which is the height, plus the base squared equals c squared. And I have a reason for making b squared the subject. To make b squared the subject, we say b squared equals c squared minus 20 squared. Well, that's going to be 400. I'm going to call that equation 6. Now, here's something very clever. If we come back to equation 3 and we square both sides of that equation, we'll have b squared equals 50 minus c all squared. This is a binomial expansion, and in Year 8 we haven't done that yet, so we're just going to yeet up into Year 9 for a second. 50 minus c all squared is 50 minus c into 50 minus c. Well, that means 50 into 50 minus c minus c lots of 50 minus c. Well, that's going to be 50 times 50 is 2,500. C times 50 is 50c. Another c times 50 is another 50c. And then if you've got minus c times minus c, that'll be plus c squared. Now, we can gather like terms, and then what we're going to have is b squared equals 2,500 minus 100c plus c squared. And in Year 10 and above, we'll teach you how to rewrite quadratics, and you would write that as b squared equals c squared minus 100c plus 2,500. The c squared comes first, and then the c to the power of 1, and then the c to the power of 0, which is to say the constant term. I'm going to call that equation 4, and you'll notice I left an equation just spare. Then we equate equation 6 and equations 4. Recall that equation 6 said that b squared is c squared minus 400, and equation 4 said that b squared is c squared minus 100c plus 2,500. Well, if we just make those equal to each other, we have this expression. And that's not nearly as bad as it looks because we realize that c squared appears on both sides of that equation. Now, if we subtract c squared from both sides, we get minus 400 equals minus 100c plus 2,500. And if we continue, we add 100c to both sides. We get 100c minus 400 is 2,500. Continuing, we add 400. We get 100c is 2,900. Divide by 100 and c is 29. And if we drop that back into equation 3, we can realize that b has to be 21. The area is half times the base times the height, which is a half times 21 times 20, which is 210.